He's an OG in this game. All right, yeah. Roland is an OG in in this uh, this field of tech, not just like cloud native stuff, but of tech generally. When we met, we got to really catch up, and it was going back to the ages of how tech started in Nigeria. So Roland is here, and I'm really excited about the his session. I look forward to it. Just before we get into that, just to ensure that we are clear on some things. After his course, after his presentation, we'll have some question and answer. You get to ask questions, you get to ask him questions and all of that. You can, if you also have questions, you can put it in the Q&A aspect of the platform or on the chat. You can do that as well, so he can also be taking that as it's going. Let's try to make it interactive, but also organized. So don't just unmute just like that. Maybe if you have a question or something, you can raise up your hand or notify on the chat. So that we can be a bit more orderly. Um, Also note that after the Q&A session, we will have our famous live quiz, session for just a few minutes, so that you can. And I want you to know that these are actual, KCNA sample questions. Do you understand? So it's very possible that some of these questions you'll actually meet them on the in the exam itself. So I want you to take note. I know somebody asked last week that I send the questions from last week to the Slack. I completely forgot, and I'm sorry about that. But I will do that this week, or, maybe after the course, after the session, or maybe tomorrow. I'll do from for last week and also this week, and send it to the platform so everybody sees it. So yeah, so saying that, this is to notify you that we'll have that live quiz like we did last time. And so please note, get ready. I also sent a link in the message I sent on the Slack. You can just open that, just leave it in your browser. So once the session starts for the quiz, you can just quickly enter the 5 digit or 6 digit pin and get into the quiz. So please, so that we don't have the kind of protest that we had last week. All right, so that's then if you okay, then finally I want to say that the recordings of these sessions are available. You can go to on the Slack channel. You will see there's a tab up there that says recordings. So when you click on that, you'll see that currently we have just week one, but by the time we are done with today's one, we'll have week two there as well. Okay, I think with that we are ready to go. Unless anybody has maybe like questions or something they want to say regarding this week, before we move on into the new week. So let me just see your thumbs up in the chat if we're good to go. Good to go. Good to go. We won't move forward if I don't see reactions. Okay. All right. Robinson, Dennis. All right. Thank you. You guys have saved everybody. If not, this well would have just been here. All right. Thank you very much, everyone. Enjoy the session. Roland, please take over. Hello, Roland. Can you hear me? Hello, Roland. Can you hear me? You're muted. Can you unmute?
Yeah. Hello.
Yes, you're good to go, please.
Hello.
Thank you.
All right. So can I hear from the audience? I just want to be sure my audio is good enough.
Sorry, Roland, your audio is not clear. Is there something you can do about it?
Okay.
Hello, Roland. Is there something you can do about your audio?
How about now? Is it clear now?
Can you talk some more so that we can
Oh,
test them? Can you talk some more so that we can test them?
can you hear me now? Is it better?
I think it's better. Go ahead. I think it's better. Go ahead.
Okay. Good day, good evening, good morning, good afternoon, everyone. Wherever I am from, good day. I bring you greetings from Calvary. So my name is Joseph. My name is Joseph Roland. So I'll be facilitating today's session on Docker or containerization, but our core focus is going to be on Docker. So before before I before I get into it, I like my class to be very interactive. Right? So that's the only way I can get to know that. Oh, okay, you are getting value from what we are doing here. Okay, so um, if you have any question, you are free to post me right. Or before you post me, just indicate right on the chat or sorry, with the thumbs up, this the emoji. Okay, I post me right. You can bring it back. So let's make it very interactive. It shouldn't just be me just talking. Okay, and so I want to give honor to my, my senior boss, Ilaria Ayo. So thank you for having me. Thank you, Daniel, and then thank you for all the organizers. Thank you for all the participants for um, taking your time to be here. I mean, you should have been somewhere else. Today, Saturday, there's so many Owambe that is happening around. Okay, so but just to to come here to learn one or two things. So yeah, I appreciate you for that. So let's look at container, right? Let's understand what a container is. Okay, what kind of container are we talking about? Is it the next container, right? The we see in Apapa War, the one we see at Tele or wherever. What kind of container are we? What kind of container are we looking at, or are we going to be discussing? Okay, so we'll be looking at Docker. I'll show you how to set up. Um, how you can set up Docker, right, in your own environment. Oh, okay, so I'll show you how to set up Docker in your own environment. I'll show you in your in my operating system I'll be using Linux. Okay, so please let me try and shut down some things that's affecting the audio quality. Um, okay, Daniel, is it better now?
Can you talk some more so that we can confirm?
Talk some more so that we can confirm. Okay, hello. Mic check, mic check.
It seems better. Just keep going. Yeah.
It seems better. Just keep going. Yeah. Okay, so I think I need to like shut down some processes that are running. Also like check my. Um, How about now? How about now?
Yeah, that sounded better. Yeah,
Yeah,
that sounded better.
that
Yeah,
sounded better.
yeah,
Okay, so yeah, that's my piece here. Okay, all right, so one of those things. So yeah, so let's get into it. Um, what is container, right? What do we understand by the word container? Anybody? Have you come across the word container before? What do you understand by the word container? What do you think a container is in relation to maybe deployment, cloud native, anybody? Anyone from the audience? What is a container? Or have we heard of the word container before? Anyway, um, hi Osinachi. Okay, hi Joy. Okay, so Osinachi, can you unmute? What do you understand by the word container?
Okay, from my basic understanding, a container is my basic understanding. A container is. I think I'm echoing. Can you mute, please, Joseph? I think I'm echoing. Can you mute, please,
Oh,
Joseph? Okay. So a container is like a basic isolated Linux, or let's say Unix process group that's that contains all the dependencies required to run an application, right? Most containers are like built around a a very slimmed down version of an OS image, right? So yeah, I think that's my basic understanding. So it allows you to do things like SSH into containers, and you have like a shell process, and the container is isolated from the host network and the host file system. So everything that goes on inside a container is contained inside there, except you purposely connect it to the host. So like an isolated process group that emulates an operating system.
okay. Thank you, Osinachi. Thank you. Joy, Joe.
So for me, I will. Okay, there's an echo. Okay, for me, I'll say that a container. Please, can you hear me? I'm hearing myself. I'm having a feedback. Hello. Okay. Okay. Sorry about that. I will say that a container is like a running instance, right? That is created from an image. So this image is more like a box that before we have a container, we have to have an image. So I'll say that the image is like a box that contains like the application code, the source code, the dependencies, the user space libraries. So instead of you using VMs, like having multiple virtual machines, a container just makes you like I don't know how to say but more like you're running processes on your system kernel instead of on the using the system's CPU and resources at the same time. So it's more like a box. Let me say it's a box that is used to run application independently from the host. Just the little container makes use of while running is the your host or your laptop system kernel. Yeah, so that's what I understand by container.
All right. Thank you, Joy, and thank you, Osinachi. So I like what both of you say. So when we are talking about a container, right? Sorry. Okay. So my name is Joseph Roland. Um, this is a bit about myself, and you can follow me on Twitter and sorry on Twitter X and LinkedIn, Joseph Roland and Twitter boss. So so yeah, we're going to be looking at what a container is, installing and then running Docker, right? We're going to see how to build a Docker image and then push that Docker image to a registry, right? Docker Hub, and then we see how to run container, and we'll also work with container or network or Docker network and then Docker volume. Okay, so um, when we look at container, when we say container, right? Before I go into why we have container and why container is needed, right? Let's go back to how we used to run application in the early days of um, of tech, right? Um, I believe every one of us here we are all engineers, whether you are a cloud solution architect or you're a DevOps engineer or you are a software engineer. I believe we are all tech inclined, right? Do we have anybody who is coming from marketing or medical doctors among us? Anyone like that? So, um, in the early days, right, we used to run an application on virtual machines, right? And so we spin up VMs, right? We spin up VMs and then we run our maybe web server and applications, right, on the virtual machine. Okay, but the problem with that is that was that VMs were very heavy. Okay, it was very heavy. It requires a lot of you know management. It requires a lot of um, configuration and resources. So it wasn't very easy, right, for engineers to manage application. It wasn't like very flexible, and I mean it scales, right, but it doesn't scale as fast as you want to. Okay, so that was where container came in. Well, let's just understand what virtualization is. Okay, so virtualization. So I'm going to just let's take it from the very beginning and then we are going to build up on that. Okay. So what is virtualization? It's process of creating a virtual version of a physical resources. Okay. This could be a server, right? You can have a virtualized server, you can have storage device or a network. For some of us, I know how many of us uses Windows operating system here by show of hands? We use Windows or Ubuntu. Okay, Windows. Okay, so now when if you're running a Windows operating system, right? The base OS is in Windows, right? The base OS is Windows. Now, if you want to run another operating system on that particular machine, right? It is not possible for you to run two operating systems, okay, in a single machine, physical machine, right? But with the help of virtualization, okay, with the help of virtual machine, you can be able to run multiple applications. Now, what happens is that the virtualized software, right, or the VM, the virtual machine, maybe you are running VMware, right? If you are running VMware, or you are running VirtualBox, or any other virtual machine that exists out there. Now, what happens is that that VM is sharing your hardware resources. Okay, it takes the hardware resources that you have and then uses that resources to provision other environments. Okay, so and it does that with the help of what we call an hypervisor. Okay, so an hypervisor is the engine, okay, is the process that manages how your VM, how your virtual machine, uses your hardware resources on your machine. Okay, so it shares things like your CPU. Sorry, please, the AC is getting into my. So your VM shares things like your CPU, your your memory, your storage, all the hardware resources, power and everything that the operating system needs. Okay, that's what your the virtual hypervisor takes care of to ensure that the operating system, right, runs very efficiently. So in the past, right, we're building application using VMs and all that, but there were limitations, right? Because like I said, it takes a lot of resources for you to manage, and then because VMs are very heavy, okay, VMs very heavy, so it takes time for it to boot. So that was where in 2010, right, the idea of being able to manage application deployment um, efficiently, right, came in. Okay, and we'll go back to the whole history of why Docker was created in the first place. Okay, so a container is a lightweight. Okay, it's a very lightweight and portable, isolated environment. I think someone already mentioned that, right? Um, for running application. Okay, so um, containers package an application and all its dependents, libraries, runtime, all the configuration files, right, that you need into into an image. And I'll give you a very good example. I remember in my organization, right, when I first joined, right, they were not using containers, right? They were not building application based on containers. They were building application based on the old waterfall model, right? The old waterfall model that we have. So, which means that I know we still run like monoliths, right? But then, those stage where you build your application, you push everything to GitHub, and then from GitHub you pull the application, you set up either a Linux server, right? And then you install all the necessary dependencies and everything, and then maybe if it's a Node.js application, you run PM to keep the application running. So what happened was that the engineers, right, they were building this application using a Windows operating system, right? And then I was setting up a Linux server to deploy the application. So after I pulled the application code base from GitHub, right, and then I've done all my configuration on the server, and then I deployed the application. Application was not working. I said, okay, what is going on? I tried everything. I thought, okay, maybe it was the version of the virtual machine I was using. So I set that particular server down and then deployed another one. It wasn't working. So I went back to the engineers, like, okay, this application is not building. What is going on? Can you check? And then they came back and said, oh, okay, I think the senior engineers came back and said, oh, everything is working in my own test environment. He said, okay, maybe check whatever. So I went back again. I did the same thing. I cloned another application. So I cloned another application and everything was working. And then I picked this application again, and then I picked my environment, wasn't working. So on production, it was breaking. But in their own test environment, it was working. What happened? Nobody knows what was going on. So I started inspecting, what could be wrong. Then I realized that, okay, so I now observe that, so when you are using Linux is very strict with how you reference parts, right? So the way they reference the part in Windows, I mean, because Windows and maybe Mac OS, they just, I mean, they take things and so okay, it wasn't even a part, right? It was a name convention. So in Linux, if you are using capital letter, right, whatever environment that you are, whether you are in test or dev, okay, if you are using a capital letter, it expects a capital letter, right, when you are running it in production. So what they did was in Windows, they use they use a capital letter, and then when they are trying to reference the application for deployment, they use small letters, right? So when I just looked at, okay, so I now look at the part and okay, from here to here, something is missing. So I went, changed that, and then reviewed the application, and then boom, everything works. After that, they did another change and upgrade, and then they changed something else. This time around, package was missing. I'll call the engineer. What is going on? He said, oh, everything is working in test environments. In our own dev environment, everything is working. All the intents, they confirmed that, oh, application was working fine. But when I take it to my own environment, right, it breaks. So what happened is that there's no consistency on how application behaves across all board. Okay, so this is why container comes in, because with the help of a container or Docker, okay, with the help of Docker, when you build an application, right, and then you Dockerize it, okay, and then you take it, whatever environment that you are in, whether you are building that application in, if you are going to deploy that application in a Linux server, or you are deploying that application in a Windows server, as long as that environment supports Docker, everything is supposed to run seamlessly. Okay, so container takes away those configuration drifts. Okay, it takes away you know, inconsistency, right? It takes away a lot of, a lot of hassle that you have to worry about. Okay, are you with me? Hope you hear me. Hello. Hello, can you hear me?
Yes, we can hear you.
Hope I'm not talking to myself alone. Okay. So what are the key characteristics of containers? Okay, so containers look at lightweight. So containers share the host operating system, okay, which is the OS kernel or kernel rather. Okay, so what is a kernel? For those of us that is, if you use a Linux operating system, so a kernel is like the engine, right? Just the same way. Look at a kernel is to a Linux what hypervisor is to virtualization or a VM. Okay, so how your hardware interact with your operating system, that's what kernel is. Okay, so container shares the host operating system, which is kernel, okay, making them smaller and faster than virtual machines. Okay, so it is very light for you to run. Okay, so when we are working with a container, we are working at the operating system level. Okay, we are working at the operating system level. So because a lot of things has already been abstracted, okay, because a lot of things has already been abstracted from different layers, so it just makes it easy for the container to boot, okay, and then run. So it is isolated. Each container operates in its own environment, independent of other container. So which means that you can run multiple containers, right, in the same environment, and then there won't be issues. Okay, and container is very portable. Container can run on any system that supports container runtime. Okay, so any operating system that supports container runtime, right, can run your container application. Okay, so it is Docker engine or a Kubernetes service, and it is very, very consistent across board. Okay, if you take your container from this environment to another environment, as long as this container or container runtime or container Docker engine in that environment that supports container, right? You shouldn't have any issues. Okay, so already I think I've talked about this. So container uses container runtime. So container runtime are like engine, that manages your container, which is very popular one is Docker D, right? To manage resources and ensure isolation. Unlike virtual machine, containers do not require a full guest operating system, which makes them more efficient. So technologies like C groups and namespace. So Hilary already talked about this in our last session, right? So he talks about C groups and then namespace. Okay. So technologies like C groups and namespace in Linux provide resource control and isolation. So now so this is it. Now in this image here, right? What you're looking at here is when you look at containerized application. So you can see that this is Docker. So Docker sits at layers, right? Now this is the infrastructure layers, which is the your hardware, right? Your hardware resources, and then you have host operating system. Now Docker sits at the top of the host operating system. Okay, and then you can run containerized application here. Okay, so because it is not interacting with the hardware, okay, because it's interacting with the hardware, it makes it easy for this container to boot up, right, and then spin up your application. Unlike your virtual machines, okay, unlike your virtual machine, which needs the hardware and operating system to interact and then boot before the application can start running. Okay, so I think we'll come back to this. So this is how the architecture, right, works. Now you have your Docker daemon, right, which is your Docker daemon is your Docker engine, that handles your the container processes. Okay, how things happen under the hood. Because when we run, so when we run Docker run or Docker pull or Docker push and all that. Now some things are going on right behind the scene that you don't know. So what is taking care of that is our Docker daemon or what you call the Docker engine. Okay, so when you run the Docker pull, right, it goes into the registry. Okay, Docker registry and then pull that Docker image and then bring it to you. When you do Docker, okay, so we're going to see how this works. Well, this is just to show you the diagram that it is the Docker engine behind the scene, right, that controls everything that happens when you interact with your Docker container, where you are running it as a container and the way you are running it as an image. Okay, so even when you do your networking, things like your volume, so how those processes run efficiently, the Docker daemon or the Docker engine is the one that manages all those activities behind the scene. Okay, so we'll come back to this when we start our when we get into the demo. So why use containers? Container is very fast, right? It's fast on startup. In terms of resource efficiency, it manages resource very efficiently, right? Because you don't have to, you are not interacting with the hardware, right? It works at the OA level. Okay, so it is very scalable, right? Easily scalable and easy scale application up or down. Okay, so which means with the help of things like maybe Docker Swarm, right? With the help of Docker Swarm and um, Docker Compose, okay, you can run multiple containerized application. Okay, if you want to really want to like change your container, your image template, you can scale that tear that down. You can also like make edits in your Docker file and then build it and then deploy your application. So deployment is very easy with the help of very few commands, right? Easily scale. So you can easily boot your container application. Okay. So yeah, why use Docker? This is just a diagram to explain my last slide. So at this point, I don't know, do we have any question before any further? Any question from anybody? Toby, do you have a question? Hello, Toby, do you have a question? If you don't have a question, can you mute your mic? Your chat. Yeah. Any question from anyone from the audience? So can I move on?
Yes, please move on.
I think you can move on here.
Okay.
Although there's a question on the chat. The demon will not leave the demon and attack. The demon will not leave the demon and attack. The demon will kill him. So the demon will kill him. So
Sorry, Daniel, when you are reading question, are you reading it up or down? Up or down? So I'm to this platform. Sure.
don't worry, just go ahead. That was a joke. Don't worry, just go ahead. That was a joke.
Okay. So so let's look at Docker history, right? So Solomon Hykes is the founder of Docker. So he started a company. I don't know if Larry, I think Larry mentioned this. So he started a company called .cloud. Okay, so .cloud was supposed to be what do you call it? The hashing copies, right? Which is more like a service provider, right? And the whole idea was to come up with a method that makes it very efficient to run application, okay, either on the cloud or on-prem, and then maintain consistency and scalability. So he came up with the should I call him, he invented, or he built the Docker Docker platform, or what has come to be the very popular Docker that we use today. And then he made the presentation of the first. He gave a speech. I think that was in 2013, I guess. I think 2013. Sorry, let me see. And there was Pi conference. Yeah, so presented Docker at PyCon in 2013, I think, and it became very popular. So people started adopting it, and then because of how efficient it was, so it was adopted. And then I think in 2015 they formed the Open Container Initiative, which is a body that controls the container standard, right? So the Open Container Initiative is not just for Docker, right? So anything that has to do with container, so they're the bodies that control standardization when it comes to containerization. Okay, so basically that's just a short slide, but I don't want us to because we have more hands-on to do. So the first thing that we're going to do is that we're going to run. We are going to get into the demo and then see how to install. See how to install Docker right in our environment. So I'd like to know what environments are we using. Are we run Windows? How many people runs on Windows, and how many of us run on um, Linux operating system? How many of us run on Windows? How many of us run on Linux? Yeah, Windows and Linux. Okay, so I have a virtual machine, right, set up. So already I have Docker running on my host machine. But what I'm going to do is that so I want to spin Docker. I want to run Docker in an environment. So I'm going to be demonstrating how you can set this up on Windows and also a Linux environment. Okay. Okay. So okay. So inside my Ubuntu VM, right? So the first thing I'm going to do, right? So to install Linux, okay, to install Linux in your operating system, so to install Ubuntu, Docker in your operating system, right? We're going to make use of the Docker website, okay? So Docker has a very rich documentation that we're going to be leveraging on. So the first thing you do is come to the home page, okay? Or you can just search on your browser app, Docker. So once you type Docker install, okay, Docker install. So it should bring you to their homepage. Okay. So you can see install Docker engine, install Docker engine on Ubuntu, install Docker engine on Windows. Okay. So I'll come here. Then you can come to get Docker. So click on get Docker. Okay. So if you are running a Windows operating system, so you click here. You are running you want so we're running Docker desktop. Okay, because I mean Docker desktop
Yeah, sorry. I'm trying to call Roland to just to know what's going on. Maybe he's his network or something. Just a minute, please. Sorry, it was network, and he's trying to rejoin. Um, yeah, sorry. He said his router went off, so he's he'll be joining in shortly. Sorry again. But let's just maybe begin to get some feedback while he's trying to come back. So how is this? How is this going for us? How is there any that maybe some of the things that you've heard so far regarding Docker is new? This you find this new to you, or you're getting some new knowledge from this? Because I know there are some people here that will be saying, "Ah, this is too basic," because we're talking about Docker. All those people that were getting first and second in the last quiz. Okay, Roland, are you back? Hello, Roland, are you back?
Can you hear me?
Yes, we can hear you now. Please go ahead. Yes, we can hear you now. Please go ahead.
Okay. So to install Docker on a Linux operating system, right? So the first thing you need to identify the operating system that you're running or your host operating system. So for me, my virtual machine is Ubuntu. So what if you are running, Debian, which is if you are running Debian or you are running for example, the Amazon Machine Linux or Red Hat with CentOS family, okay, just come here and then click on this basic on any of the option based on your host operating system. So I'll click on Ubuntu. Okay. So the first thing we need to do, right, is to update our operating system. So to do that, I'll run sudo okay. So I have to load the VM again. Okay, so let's update our machine. So we run sudo apt update. Okay, so after that, come here, right? Now you don't need to, cram anything. The Docker documentation is very detailed. So just come in here right? Copy the command and then paste here. So this will install everything that you need. So while we are waiting for this, okay, while we are waiting for this, I want to quickly set up my Windows VM. Okay. So come here. So the installation is complete. So let's run Docker version. Okay. So I need to run sudo apt install Docker. Okay, so come here, Docker
My love, my love, my love. How are you, my love? Why are you looking like that? I don't ask. You know what you might get before.
think. Okay, so now this is my Windows operating system. So I'm just going to double click. So now when you are using Windows, okay, so because right under the hood, Docker uses a Linux kernel. So what Windows does is that they have what is called WSL, which is Windows Subsystem for Linux. Okay, so that is what Windows is going to use. So instead of Hyper-V, right, it is going to use it is going to use WSL, right, to run the so um, okay, so click on OK. So this will install all the dependencies and all the packages that you need. So while we are waiting for the Windows installation, right? So let's go back and look at our Linux. Come here and run version. Okay. Docker not found. Okay. So since Docker is not running, so what we are going to do is just come here, right, and then set up the Docker repository. Okay, so to run Docker desktop, you need to install the Docker engine. Okay, so to install the Docker engine, so what I did was to come in here and then copy, so copy this command. So it's going to run everything, right? All the Docker installation as a bash. So it's going to run it in form of a bash script. Okay, so Docker C, Docker D, all the Docker all the Docker dependencies and everything that you need, okay, is packaged into this bash script. So this is the fastest way, right, to get Docker running. So most times the problem is when you try to run, if you try to use the Linux package manager, which is the apt. So if you run sudo apt get installed, right, it breaks. It doesn't work most times. So the fastest way for you to get efficiency is to use the bash script method. Okay, so now we have Docker. So to check if Docker is installed on this machine, okay, so you do Docker version. So with Docker version, okay, it tells you that the Docker engine is the community edition, and this is the version of Docker that we are running. Okay, so let's go back to our Windows operating system. Um, lost. Okay. So which of these? So for Windows, after you So for Windows users, after your installation, right, Docker will ask you to reboot your system. Okay, so you do the reboot. So as you can see here, we have Docker desktop installed on our Windows machine. So it is very fast, right, and very easy to get Docker running on your Windows operating system. Okay, so come here, accept, and then this should open. So this should open Docker desktop for you. Okay, so you come here, you do all the necessary setup. Hold on. So you do all the necessary setup, put your email address, or just going to skip this and then skip this. And then so allow Docker to do all the necessary setup for. So this is how you can get Docker running on your Windows machine and then on your Linux machine. Okay, so we have Docker engine running on both our Linux and our Windows. So the next thing is, let's see how we can run our first container. Okay, so if you are new, how do you get your container? How do you know what to run if this is your first time? So like we said, what is a Docker container and what is a Docker image? So for you to run a container, right, you need an image. Okay, for you to run a container, you need an image. So can anybody tell us what a Docker image is? Anybody? What is a Docker image? Anyone who wants to help us out? What's a Docker image?
Yeah. Can I give it a try? Can you hear me?
Yes, I can hear you.
All right. So I can say, right, a document image is a snapshot of our application the Docker, instructing the Docker engine on how to restore dependencies, right, when it is being run in the container. For instance, if you want to containerize a .NET application, right? Part of the starting point of the Docker image you will be building, you will be specifying the version of the .NET that you want the image to pull, right? You will then also be specifying the path of all the projects or dependencies. You be specifying the path of all the projects you want it to restore, which also contains all the dependencies that the application requires to run, right? The same thing also applies when you are building an image for a Node.js or any other framework you are using in the application development. Yeah, that's it from me.
Okay. Thank you. Okay, so Samuel, can we get your
Hear
contribution?
me?
Quick.
Can you hear me?
Yeah, please can you make it very snap and short, very simple.
Yeah, sure. To be concise, so I would say Docker image is a prepackaged executable that contains your application, which is your code. It contains the dependencies it needs. So it basically contains the application and the dependencies it needs, such that it can run in any environment, and you can use the Docker image to create a container.
Okay. Okay. So thank you. Thank you, Samuel, and thank you, a yellow, right?
Yes, Enyelu.
All right. Thank you, guys. So when we say a Docker image, right? A Docker image is a template, right? It's a template or a package, right? And that package contains all your. So imagine you have an application, and then you bundle that application, right? All the dependencies, all the. So let's say you're running like a Node.js application, your Node modules. Or, I mean, when you build your application, when you build the application into, and when you write a Docker file to build the application, right? It builds, it downloads and then install your node rules, your package.json file, all the package.json and everything that application needs, right? So what it does is that it creates a template, right, for that application to run as a, okay? So once you do that, once you write a Docker file and then you build that application, right, you now push it to a registry or a repository, okay? Just like we have GitHub, right? What is the importance of GitHub? GitHub is a server, or we call it a storage bucket where application code to, okay? So that anytime you need it, you can pull it again. So the same, just as we have GitHub, we also have Docker Hub, okay? So the Docker Hub is where you store your Docker images, okay? So now, for us to get a template to run as a container, okay, we do? We go to Docker Hub, okay? So we go to where? We go to Docker Hub. So come to Docker Hub. Sorry. Okay. So when you come to Docker Hub, so this is Docker Hub. Okay. Now, let's say you want to looking for you want to run an Nginx, right? You are looking for an Nginx image to run, or you are looking for a Python image. You are looking for a Node.js image, right? Come to Docker Hub and then search. So if I come and search for Nginx, okay, so you see all the Nginx images, right? You see all the Nginx images here, and then you also see the author. Okay, so this chart shows the activities, the numbers of pulls, okay, for this particular image. So as you can see, from December to January, it has maintained a steady, steady graph, okay, and you can see the numbers of downloaded people, the numbers of pull, okay. Then so whenever you are pulling an image from the registry, it is important that you know you pull image from a trusted publisher. Okay, pull image from a trusted publisher, because Docker Hub, just like your GitHub repository, is a public registry. So what that means is that anybody can build a Docker image and then push it to the to Docker Hub, right? And then you can go and then pull that image, or you can go and clone that image, and then you run it. So you can be lucky to run malware, on your system. So when you are pulling your image, ensure you are pulling from a trusted publisher. So you can see the official Docker image here, right? You can see verified publisher, right? You can see people that are like sponsored. So what you do is you can use the tags, okay? You can use the tag to filter, maybe from, you are looking for official image, maybe for Node.js and all that. So once you use the Docker official image, you filter it, you can see that it has filtered the main image. So you can come in here, right? Click on it. Okay, so this gives like the supported tags. Okay, so these are tags for this particular base image. So this Nginx, right? This Nginx is the base image, and then you have like other tags. Okay, so these ones are like different versions, and then you have like lightweight. Lightweight is that you can run. Okay, so if you want to run this particular image, you copy this and then you do Docker pull. So this will pull this image, okay, to your this will pull this into your own local machine. Okay, so I want to start my Docker desktop. Play this. Now,
I think he has gone off again. Really sorry about these network issues. It's out of our control. But are there any questions? Is this clear so far? Are there anybody has questions that you want us to discuss before he comes back? Um, okay. Okay, and yeah, please go ahead.
All right. Can you hear me?
Yes, I can hear you. Please go ahead. Yeah.
I just want to be able to recap what was said earlier, right?
Okay.
So the Docker file, every application has a Docker file,
Mm-hmm.
and then the Docker file contains sets of instructions on how to build the Docker image,
Mm-hmm.
right? The dependencies to restore and everything that you need for the application to run, right? Those instructions are contained in the Docker file, right? And
Mm-hmm.
then when you run the Docker build command, right,
Mm-hmm.
it then packages the application, right, and its dependencies based on the instructions on the Docker file into an image, right? Now,
Yes.
that image is being pushed to Docker Hub or any other container
Repository.
registry on Azure or AWS, right?
Mm-hmm. Mm-hmm.
Now, from that container registry, right, the image can be picked and then run in any container, right, of our choice, right? And then we
The
have
image can be pulled and used to set up and used to start a container. Yeah.
exactly. So the image can be pulled and used to start up a container, which is our application in essence, right? All right. Yeah. Just want to have an overview of the process
Okay.
again.
Yeah, that's essentially the
Mm.
flow. So think of it as so I like to use analogies a lot. Think of the image as a blueprint, or so, or if you I don't know if you have background in programming, think of it as a class, and then you now have instances of that blueprint. Uh, so yeah. All right.
Yeah, I think that's clear enough.
Hmm. Okay. Any other one? I've sent. I'm reaching him, and he's. I don't know what's going on. We might have to. We might have to cut it short. I'm seeing some people. Somebody's asking a question on the chat. Say after installing Docker desktop. Okay, Joy, please go ahead.
Okay, so for me, I've read a bit before this class, so I'm a bit confused with something between Docker Compose and Dockerfile, right? When can you use Docker Compose and when can you use Dockerfile, and like what's the difference? Like, what makes is it that Docker Compose is better than using normal Dockerfile? So I'm kind of confused trying to understand this
How
how
they relate. Okay.
yeah, how they work and situations where you can use them.
Okay. So, but do you understand the whole concept of, um, you have this, you know, this image, right? This image that is running an application. So the idea is that is like a small. Just imagine a small computer that is just running one thing. Do you understand? Just imagine it like that, and then it's just very small and it's running on your on it's running on top of the Docker this thing. So it so ideally you just have, yeah, it's not like it's not possible for you to have more than one application inside a Docker container. It's possible. I mean, people do that, right? But usually most times what you have is that you have one application inside one container, right? So now, what now happens if you want to have different containers, right, on the same network, able to access the same resources. When I say resources, maybe volumes or things like that, because maybe they work together. Do you understand? So an example would be maybe you have an application that uh, so you have it. Maybe you also need you have a small database server, maybe a Postgres server, or maybe a Redis server. That you want to run together, but it doesn't make too much sense for you to have a Postgres server and your application server running inside the same small container, sharing that small resource. All right. But it makes sense if you are maybe running a Postgres server in one container and you are running your application in another container. Now, those two need to talk to each other, right? Those two containers need, remember, it's like two computers, they're separate, they are isolated, but they need to talk to each other. So it means that you need to think of the network. Upon what network would they connect together, right? You need to think about, okay, there are the volumes and all of that stuff, right? So you now begin to go into a situation where you need those containers to exist together and they can share resources. So that's where Compose comes into play. So with Compose, you are able to with Docker Compose, you are able to define different applications, different, or rather, let me say different images. Do you understand? That will run together. I don't know if that makes sense to you. Hello, can you still hear me? Hello.
Yeah, you're audible. You're
Yeah, I
audible.
can still hear you. Sorry, I'm having
Okay.
issues with my distance. I can still hear you.
Okay.
So,
Yeah.
but
Does
it's a
that
bit confused. Like for me now, with explanation, I'm still confused
you're still
because
confused?
why I'm asking
So
that there is a YouTube tutorial I watched where the
okay.
person used both Docker, Docker file, and a Docker Compose on one, like containerizing one application, the same application. There's a Docker file and there's a Docker Compose. So that's where I'm like, okay, what
Okay.
is really
You're
going
you're
on?
not sure of what. Okay. Docker file is where
I
the
don't even know.
conflict
I
is.
don't. I want to understand the difference.
So Docker
The
file.
Docker file is there, and then the Docker Compose YAML is also there.
Okay. So let me explain this now. So you've written your application, right? And let's say it's a, Node.js based application. Let's say let's just say Next.js, right? So it's based on Node. You need your Node modules, some dependencies, right? So you have this Docker file, right, that defines all the dependencies that needs to be inside that container for that application to run successfully. So your Docker file is just a list of instructions that, okay, do this, install this package, um, run this script, expose this port. All right. So that's what your Docker file is doing. It's just a list of instructions on how to build the image. Do you understand? The idea
Okay.
is,
Yes.
how can we build the image? That's what the Docker file is helping you do. It's just giving instructions. Do you understand? To build the image. That is it.
Mm.
Now, Docker Compose is later down the line. All right. So you have your application, you have maybe some other things. It helps you run different Docker images. Do you understand?
Okay.
Different Docker images, not necessarily just one now, not just your application, but other Docker images as well, right? Docker Compose helps you run them together. Okay, is that clearer? Is that better?
Okay.
Hello.
Okay. Now I guess. Yeah, I'll read more, but it's a bit clearer than when I read about it. Thank you.
Okay. So what's your background? Let me ask. What's your background?
Backend, and I transitioned into DevOps. So
Okay. Have you used Docker before? Like, have you used it?
yes, 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 yes. So what
You
I'm
use
used to is
okay.
Dockerfile, right? But where I am, because I still do backend and then gradually transition into DevOps. So where I'm currently working, the team lead was talking about that we have an application, but it's a Java application that we want to make use of a a Docker Compose YAML file, and that he
Okay.
wants to configure some network and some volumes. That's when I was like, what's going on? This is not what I'm used to. So he's now said I should make research and read about it. I came back and I told him I didn't really understand the concept of what's really going on with Docker Compose this thing.
Okay. All right. So yeah, it's similar to what I explained earlier. Talking about a common network, common volumes. You can define all of that different images should use. Do you understand? And share together. Do you get? So just take that. Since you're back end, right? By the time you go back and play with, so you build an application. Maybe you quickly do sorry, maybe you quickly do a small backend application that talks to a Postgres database. All right. Now, there is also, so you define a Docker Compose, right? Apart from your Docker file now, you define a Docker Compose that will run your application and also run um, the Postgres container as well, the Postgres image as well. All right. So try that. By the time, because some of these technologies, when they're explaining it to you, you might not understand it, but as you are using it, that's when you begin to connect different explanations. Do you get? Uh, but it's nothing more than what I've said. It's nothing more than just what I've said in terms of being able to run multiple image containers. Okay, so I think at this point we should move forward. I don't think Roland is able to get his network back up to meet us, and even if he does, we're already out of time. So, are there any other questions that's or anything else you want us to deal with before we move on? Hello, anyone? Anyelo, please go ahead.
Yeah, thank you. I just want to throw more light on what you explained, if I may.
Please go ahead. Yeah.
All right. So I see Docker file. I see Docker Compose file the way I see Kubernetes, right? They are both used in orchestration of our application system, right? Just as you rightly said, we use the Docker Compose file to specify. Okay, just to put it right, every application must have a Docker file, for instance, right? And then that Docker file is being called, right, in the Docker Compose file, right, with other services as well, such as the databases, right? Um, 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 if you are using source like Redis, for instance, for your caching, right, in your application, you can also call that in the Docker Compose file, right? Instructing the application on how to run, right? The databases to talk to, for instance, the Redis application to communicate to, right? So once you finish configuring that in your Docker Compose file, in a single file, you can run it, and it gives you exactly what a Kubernetes can also give to you. So in essence, a every application would have a single Docker file, for instance, which is then called into the Docker Compose file, right? You can also call more than one Docker image, right, in the Docker Compose file, and then in line with other dependencies, with other images like your database, your Redis, and so on and so forth. Yeah, I don't know if that throws more light in the explanation.
Okay. Thank you. Okay. Somebody else wants to say something. Okay, Sonia, Samuel. Please just unmute. What's like, yeah.
Yeah, I'm unmuted. So I just wanted to contribute based on what I understand so
Yes, go
far,
ahead.
even from the presentation too. So Docker file is the set of instructions that allows you to create a Docker image, right? And the Docker image is just like the person that was presenting earlier said, it's like a packaged a packaged a package, a package that contains your application code and dependencies. Everything your code just needs to run. It is inside the Docker image. And because it has everything your code needs to run, it can run in any environment on your own laptop, on the server. It will run the same way, right? But to run a Docker image, because Docker image is just to create container. So to use a Docker image to create a container, you have to run the command Docker run this image, right? So if you want to run, like, let's say you have front end, back end, and database, you have to run Docker run. You have to use the command Docker run for each of them. But what Docker Compose does is it allows you to define the images in a file. After defining them in a file, what you want them to do, how you want them to run, you define it into that file. So with a single command, you can run multiple containers with Docker Compose. So that's what Docker Compose does. It allows you to run and manage multiple containers.
Awesome. Thank you very much. So who was that? That was Joy, right? That is it clearer now? In the mouth of two or three.
Yes, yes.
Okay,
Thank
awesome.
you.
All right. All right. So let's quickly move on to what we've all been waiting for. I just feel like we've been waiting for this session for this part for a while. Or am I am I wrong? Sorry, just a minute. I'm coming. Boom, 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 boom. I'm not getting any feedback. Or I said we've been waiting for this session. Nobody's giving feedback. All right. I'm about to hope you have your I'm about to start this thing up. Yeah, let's go. Somebody has said we should remove background music. Is that, do you guys want that, or we should so background music, yes or no? Just let me just see the first 5 responses and then we'll decide. Yeah, you can give a thumbs up. Please remove. Okay, okay. All right, so we'll remove it then. Awesome. Let me share my screen. What's going on here? Share screen. Window. Oh, yeah, there we go. Okay, so let's go. Let's begin to have people come in. Without music is boring. Oh, what's going on? Please, I think we need this music. Kami is the first to enter again.
I think we need to drop a link, right?
Oh, well, can you see the screen? Just
Yes, I can see the screen, but I'm using my phone, so I can't scan.
Okay. Let me quickly try to get you the link again, because the link is on the Slack. Are you not on the Slack?
I am.
Yeah, because I shared the link on the Slack, so that was what I was hoping
Let
that.
me see.
Don't worry.
Slack.
Okay, somebody else has even shared it as well. Don't worry, it's on the chat now. You can.
Thanks. Come on. And the game pin. Okay, good. Copy.
See, we are giving a lot of time now, so there should be no protests. All right, are we ready to go? We have 22 people who have already signed in, and we have 28 people on the call. So should we assume that the others are not going to join in so that we can move on?
Maybe
Okay.
one more minute.
Okay. Okay, so I think we should just move on. Everybody can agree that we waited. So okay.
5 seconds. Give me
Let's
like
go.
5 seconds.
Second. Okay. All right. Sorry, I missed the music.
All right, let's go.
Hello, hold on. I'm only seeing on your screen is showing just 10 players are waiting. I don't know if that is rightly captured.
What'd you say?
I said on your screen, I'm seeing 10 players are waiting. That's only 10 players have joined.
No.
And I don't even see my name.
No. It's 25 players that are here.
Okay.
Yeah.
Yes.
So, can we go in? For those who said we should hold on. Exactly, right?
Sorry, I don't know why I can't join.
What's the challenge you're having?
After inserting the pin, it's not submitting also. Sorry.
It's not submitting. Why?
Yes.
Your username is not long enough.
Oh. Okay.
Okay. So I think that should be everybody. If we're 28 on the call, so I think, and we have 26 people who are here, so I think that should be everybody. All right. See you on the other side. So, what is the difference between a VM and a Docker container? VMs run on Windows only, containers run on Linux only. VMs share kernel space, containers have isolated kernels. Okay. All right, so let's see the results. Nice, 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 nice. Okay, let's move on to the next one. Which command builds a Docker image from a Docker file? Which command builds a Docker image from a Docker file? Okay. Ah, Deep Bear. Hold on. What does from node um, tag 18 Alpine do in a Docker file? Okay, so let's see the results. Ah, Vicradon is here. So the answer is sets the base image to Node.js 18. Why use a multi-stage Docker build? Why use a multi-stage Docker build? So let's see the results. Okay. So the answer is to reduce the final image size by discarding build dependencies. Okay. Question. How do you persist data in Docker after a container is deleted? How do you persist data in Docker after a container is deleted? See the results. Okay. So use the answer is use volumes, as in to use volumes essentially. What is the default Docker network driver? What is the default Docker network driver? Show results. All right. The answer is bridge. Fix this command. Docker run -v /data --name my container nginx. So how do you fix this? All right. So 7 people got it. So you add the mount target to that in there. What is Docker Hub? Okay. public registry to store and share Docker images. Okay. What is the difference between CMD, that's command, and entry point? Okay. So I think this is the final question. How do you push an image to Docker Hub? Docker push, username, image, tag. Okay. All right. So let's see the final results. Wow. Gigi, Vikradon, Kami, Raman, and Tekinos. Those are the top 5. So let me request result download. Result. Is it downloaded? Okay. So they're asking who is Gigi. All right, you guys think that Alakami, I know Alakami 0 this time around. That's not fair. Sorry, I'm trying to. I know I downloaded the. What's going on here? Oosh. All right, as a reminder that I still live in Nigeria, so. Sorry. Sorry, I'm trying to share my screen so you can see live results, and we will not be accused of changing it between voting point and collation center. So can you still hear me? Hello? Hello, can you hear me?
Yeah, I can hear you.
Yeah.
Hello? Okay. Sorry about that. I'm not sure whether it was my internet now or something else that went off. All right, so I want to share my screen so you can see live results. There we go. Okay. Sorry, can you see my screen? Hello?
Yes, you can see us.
Awesome. All right. So you can take a screenshot so that by the time we paste by the time we paste it, you can by the time we put it on the Slack, you can make sure that yes, they did not tamper with it between collation center and voting point, if you know what I mean. All right, so that is it for this week. Thank you very much for your time, for your engagement, and just being wonderful. If there are questions or contributions or anything you want to add, please you can say that now. Festus, you're raising up your hand. Please go ahead.
Yeah, I'm not on the Slack channel. Good evening, Daniel. I'm not on the Slack channel.
You're not on the Slack channel?
Yes.
Okay. So, but how did you not get the link to join here?
Yeah, I'd registered for the event the very first time, so the link was sent to my email.
I see. Okay. Yeah, on that same email, the link for joining the Slack channel is there.
Okay.
Am I right?
Check, but
Yeah,
I'm not sure.
because that's how we shared the link to everybody. So in the email that was sent, the link for joining the Slack channel is there. You can use that.
All right. Thank you.
All right, cool. Thanks. All right. So any other questions, anyone? Okay. So awesome. Next week we'll be going into Kubernetes, and I will be the one taking that session. So yeah, we'll be looking at Kubernetes foundations and core concepts. So container orchestration principles, Kubernetes architecture, Kubernetes cluster setup, working with pods, namespaces, deployments and replica sets, services and networking. So yeah, we have quite a lot to cover next week. So I look forward to it, and I hope you are too. One more thing. Yeah, I think that's it for the week. We will, please, like I said, this week we're going to, during the week, either between Wednesday or Friday, we will reach out on the Slack regarding the James Spearing course, because the labs on that course actually start from Kubernetes. You understand? So that's why you see we're not really doing labs currently, but the labs start from Kubernetes, so which will start next week. All right. Thank you very much. It's 9:00 and it's a good time to close. Enjoy the rest of your evening and have a great week ahead. Bye.
Yeah, ciao.